If you have some code that you need to include in more than one program, and this code needs to be transactional, secure, and concurrent, you can put the code in an Enterprise Java bean, install the bean in the server, and let everyone call it from their programs. All the hard work is done for you, but you have to jump through a couple of hoops to form the bean just right so it can be installed in the server, and then you have to jump through a couple of more hoops to get it installed. I'll be showing you how to jump through these hoops in the next few lessons, but right now let me explain beans. These two are really two different things. A Java bean is a graphic display component, like a button or a label or whatever. An Enterprise Java bean is a program that resides in the server and provides your program with methods that can be called to do things. It's this second one that we're going to be dealing with here. The two kinds of beans have one very important thing in common. They have a standard naming convention that allows you to query them and find out what the commands are that make them do things. An EJB lives in the server, and the server does practically all of the hard work. It certainly does all of the communications work. Your program appears to call a method of the bean, but what really happens is your program sends a message to the server, and the server does the job of calling the method, then returning the results to you. During all of this, the server checks that the user has the security clearance to do it and includes the call in the transaction. It can even have the bean reload data from the database before the call is made. In other words, there is a lot of work being done for you that you don't have to mess with. You just need to write your code and put it in the right context for it to be called. One important aspect of an EJB is that the call to a method is a network operation. Internally, EJBs use RMI, which is the Java Standard Remote Method Interface. This way you can call a method of the bean from anywhere. Roughly, it works like this. This diagram shows the client program on the left. The client calls a method in the stub. This stub program is specially designed for this particular bean. For example, if your bean has a method named gimme5, a call is made to the method gimme5 will actually be in the stub. The stub form of the method does what is known as marshalling. That is, it converts the arguments to the method in a form that can be transmitted over a communications link and sends them to a method by the same name in the skeleton form of the bean. The skeleton then unmarshals the arguments into a local form and calls the actual method of the bean. Now, this method can call other methods in the same object or in different objects. It can talk to a database, it can do anything any Java program can do, including call methods and other beans. Eventually, the method will return to the skeleton. The skeleton marshals the return value to be passed back across the communications link and then sends the response back to the stub. The stub unmarshals the return value into a local form and uses it as the return value to the client. As far as the client is concerned, a standard Java method call has just returned with a local value. The good part is that you don't have to write all of this code. You'll have to put together a couple of descriptive things, but they're really quite simple and take a standard form. From this information, the stub and the skeleton are created. Any of the primitive data types, int, float, short, and so on, can be transmitted because any one of these can be marshaled into a form that can be recognized by the receiver. These are easy. Any Java object can be sent if that object implements the serializable interface. Most of them do, so this is seldom a problem. If you find yourself trying to send an object that is not serializable, you usually have a special situation and can usually work around that easily enough. You can send arrays as long as the members of the arrays all can be sent. Remote objects are addressed by stubs that reference them, so sending the stub is sort of like sending a gateway to the remote object. The object stays where it is and stays remote, and the access to it is sent. Okay, those are the fundamentals of clients talking to beans. In the next movie, we'll be looking closer at the beans themselves.